Good morning or good afternoon. My name is Mathias and I'm the Head of Analytics and Visualization at Anomaly. Today I'm going to talk to you about empowering self-service through Tableau. So in terms of the agenda, I just want to cover off a little bit about myself and where I work and a bit about my history. And then I'm going to dive into what I mean by self-service, and specifically within Tableau. I then want to cover off some best practices, as well as acknowledge some common challenges in promoting self-service, and share some examples of how I've used self-service at Anomaly, and finish with just some key takeouts. So who am I and why am I standing before you or presenting to you today? As I mentioned, my name is Mathias and I'm the Head of Analytics at Visualisation at Anomaly. Anomaly is a boutique research and analytics company, part of the IPG Media brand, and we specialize in media measurement and optimization, direct response analysis and strategic research. I've got a lot of experience in business intelligence and I've worked with a number of systems including Cognos, ClickView, Oracle, and more recently Tableau. So over the course of my many years in business intelligence, I've worked with a number of systems, getting them off the ground, deploying them and maintaining them. And so I've got a lot of experience on and tips that can help improve self-service and get better results through business intelligence. What really excites me is analyzing data to provide strategic direction through business intelligence. So what do we mean by self-service? Well, like many people, if you try and Google what self-service, it comes up with a number of options. Really, self-service is not any of these things that I'm here to talk about today. Self-service in the business intelligence space is providing the facility where people can do their own insight discovery, rather than relying on traditional analysts to provide data or insights. So this involves providing mechanisms so that end users can interrogate their own data and draw insights which inform their own business decisions. And the idea today is I'm going to show you ways that you can become more self-reliant or promote self-service through Tableau. Before we actually cover off ways of improving self-service through Tableau, I thought I'd start with what are the benefits that self-service can bring to any organization. The first one is improved data literacy within an organization. And this is really where you have a culture that embraces numbers or data, and people are not afraid to be reliant on information. The second benefit of self-service is that it can shift the organization from being reactive to proactive. And this means people use information constantly to their advantage, and they draw on new analysis or insights to inform decisions. The third benefit is that decision-making becomes objective and not subjective. And this is really trying to reduce the risk attached to gut feel decisions, or decisions which aren't supported by fact or robust analysis. The next one is speed up the decision-making process. Self-service can help users be more informed, as I mentioned previously, and so you can try and reduce the time taken to make decisions. And this is really reducing the red tape or ambiguity that often is inherent within most decision-making processes within many multinational companies. And so you can enable fast decision-making by employing self-service. And lastly, you can reduce the reliance on IT and data warehousing. And what this means is by having information available regularly, you eliminate the need for analyst teams to run reports. Thereby, end users can run their own analysis independently and don't have to require the need of IT or data warehousing. So these are just some of the benefits that self-service can bring. There's many others out there, and these are just ones that I've noticed in my experience that can really help promote self-service. All of the ones listed here are supported by Tableau. So now I'm going to cover off what are the best practices to actually champion and promote self-service. I'm going to list them and talk about them very top line and go through them in more detail in the subsequent slides. The first one is promote decentralizing insight discovery. And by this I mean insight discovery through business intelligence is normally centralized to analyst teams. And so this theory is trying to promote other users and the dissemination of insight discovery across the organization. So having more people analyze data and have information more freely available. The second one is utilize multiple deployment options. So Tableau supports many deployment options, and there are other ways of trying to engage information and deploy it that take advantage of the latest technology and the latest mobile trends. So one way I've thought of is to disseminate information aligned to user preferences. There's many deployment options that Tableau support whereby you can utilize current infrastructure to disseminate similar information. The third best practice is ensure data and insights can be exportable across multiple platforms. Tableau supports exportable information across many platforms. So whenever you have a graph, a table, or a chart, you can right-click on that and export it to many systems like Microsoft Access, Microsoft Excel, PowerPoint, or many other systems. You can export the data into CSV or many other systems that support the information that you're trying to achieve. The next one is utilizing some advanced interactivity functionality. So Tableau supports many functions written within Tableau that you can reference to utilize interactivity functions within your dashboards. The next one is utilizing some advanced analysis functionality. So the one before it was more around interactivity and using things to improve the look and feel or the interaction of the dashboard. This one here is utilizing some analysis functions to extend the use of a dashboard so that users can analyze information and not just have to be presented with information. So some of these, again, there are many other best practices when championing self-service, but these are the ones that I wanted to go through today. The first one, so traditional BI is usually centralized to analyst teams, as I mentioned. The example I've got here on the screen is a traditional organization, sales and marketing organization, and highlighted in orange is a function known as reporting or analytics that might sit within marketing or business support, but it's generally a team that provides business support to the entire company. So these are traditional BI users, and they're centralized to a business analytics, data warehouse, or business and customer insights teams. These are the names that they're commonly used or referred to as. Generally, these are analyst teams, and they interrogate data and disseminate strategic insights to the rest of the organization to inform decision making. So the theory here is to try and decentralize and demark the lines of traditional BI. BI does not have to be restricted to just analyst teams, and Tableau has many simple self-service techniques which can empower all users to become self-reliant. I talked a little bit top line around mobile deployment options, and mobile connectivity is really the future. A lot of users are on the go. They have information, whether it be their tablet, their mobile device, but mobile connectivity is certainly taken off and is a trend that's not going to go away in the short term. So why not configure a dashboard for mobile devices? Consumers, they have a lot, as I mentioned, have a lot of communication interaction on the go, and fundamentally technologies change to support that. And so consumers, the emerging trend is that they prefer to interact through wireless technology over conventional wired technology. This means that users are more on the go more than ever, and you're more likely to increase engagement with those users if you can tailor your dashboards to align to end-user connectivity preferences. So Tableau supports multiple deployment options, and they can be either through Tableau server, which can deploy through from a browser, through to tablet, and also onto a mobile device. So the key insight here is really make sure your dashboards are aligned to those deployment options. The same dashboard needs to be configured to whether you're going to deploy through a browser, through a tablet, or through a mobile device. And one example that you can use through those deployment options is JavaScript. So we at Anomaly here, we use JavaScript to help in our dashboards to dynamically control parameters. And that's one example where you can integrate JavaScript and many other technologies and deploy them onto, for example, a tablet or a mobile phone through Tableau. I'm now going to cover off some advanced interactivity functions, as I mentioned, which are functions that help promote interactivity within your dashboard through Tableau. So the first one is enable highlighting across dashboard. Highlighting is really a cool tool to filter or select or promote information that's of a common language or common definition. So you can use filtering or highlighting to promote common themes within a dashboard or common elements, which is a way of filtering through to the information that you want to analyze. You can geocode your data and visualize it on a map. So many analysts and many marketers prefer visual information rather than tabular. So if your information relates to anything that's on a geography basis, like a state, a postcode, local government area, or latitude and longitude, you can visualize it on a map and get better engagement with the information that you're presenting. You can also use parameter-controlled axes for coloring on graphs and for filtering. And the example on the right-hand side is a graph that I built where there are a few filters. I'm just going to point them out with my cursor. The first filter is what information you're choosing to display, whether it be new customers or existing customers. And the second filter determines what you display on the secondary axis. So the first axis is controlled, it's always fixed, but the secondary axis is a floating axis whereby you can change the information you want on there. So for example, here I'm displaying spend, but I could display impressions or transactions. And using the drop down and changing the option will change what is graphed on that, what is displayed on that graph. And likewise, the third option controls what do we display. Do we display a week? Do we display a month, a quarter, a year to date, a month to date? So using parameter-controlled axes, you can control, or the user can control, what they want to view or what they want to display and analyze. So by putting information into those parameters, you can let the user choose what they want to visualize or what they want to analyze. You can use global parameters for consistent filtering across tabs. And so if you have multiple tabs, and for example, you have a value called segment, which could be a group of customers, dissimilar to what I showed you in this previous example, I would call new customers a segment. Another example could be existing customers. But if you had common filters across tabs, using global parameters will help you filter all the data across those tabs so that you're looking at the same information and the same consistent filter is applied to all tabs. And lastly, you can use visual cues to alert users to information or to a change in information. The example here on the right-hand side is we have a table here that looks at spend by a year, and then it has an indicator, a traffic light, to tell you whether the information's changed, whether you're seeing an increase or decrease, or the values have changed the same. So these visual cues is a way of prompting the user to say something's changed, and I've summarized it being obviously if it's increased, it's in green, if it's decreased, it's in red, and if it stayed the same, it's in yellow. So visual cues are another way of promoting self-service that creates interactivity that helps promote self-service. We're now going to touch on some of the advanced analysis functionality within Tableau. There's been a lot of talk with R and the release of 8.1, Tableau 8.1, that R is now integrated within Tableau. And so you can call R procedures within Tableau to run things like predictive models or advanced statistical functions. So if you have a dashboard that needs to crunch some numbers or needs to calculate something or model something or predict something, if you've done that analysis in R, you can integrate it within Tableau and have it self-contained within the one dashboard. Again, this extends the functionality of Tableau, meaning that you can create more information within Tableau to promote self-service. Another example of an advanced functionality is creating things like a scatter plot or a two-dimensional matrix. An example we've got on the right-hand side is a graph that I've created which has 2 dimensions, and again we have parameter-controlled axes to determine what I put on those 2 dimensions. So I can control what I show on the left, on the x-axis, in this case it's average age, and on the y-axis is the average weekly income. And what we see here is a scatter plot. Each dot represents a postcode, and it shows the relationship between those 2 variables. So traditionally you might do this in Excel using a correlation function, or you might create a scatter plot or a line scatter plot. But the value you can create is by extending these analysis functions within Tableau. Again, you can provide interactive functions that are of value, where users can analyze information within Tableau, all promoting self-service. So it's not easy. A lot of those things, there are some tricks to it, there are some learning things that need to happen, but promoting self-service is not easy, and there's many common challenges. So now what I'm going to explore is some of the challenges that I've faced or I hear from other clients in promoting self-service. The first one is, how much information should I provide to my clients or to my stakeholders in the dashboard? So it's trading off flexibility versus an information overload. And what you're trying to do here is strike a balance between complete flexibility, where you're giving information freely and anyone can cut information by every different mean, versus the other side of the spectrum is that you're giving too much information and you're giving not enough. And so you're trying to strike that balance where the aspects of the dashboard, all aspects, whether it be the data, the insights, or the analysis, they're aligned to the business requirements, or they answer a business objective. I often hear that there's a lack of senior management when working with business intelligence software, and so senior management are not often bought into the process. So here, a way to remedy this is governance is critical. You need to get senior buy-in, and there needs to be compliance over the system and governance for any BI system to be adhered to. So you need to find sponsors that champion self-service within your organization and can provide top-down direction to the analyst teams or to people that are using the business intelligence software. And those sponsors, it's their responsibility to drive the corporate strategy, to find the business objectives and create the data literacy culture. So it's not only your problem to solve. You need to engage senior management, get their buy-in by explaining to them the benefits of self-service, and use some of these tips and tricks to help win them over and create that engagement. Well, often there's investment required to upskill users. So users might not be at a level where they're comfortable and competent to use a business intelligence platform, and so money is required to invest in training or infrastructure. Well, this is a really hard challenge to avoid. Let's face it, everyone needs to invest in people and technology, but put together a business case to justify the investment. Show the efficiencies that can be gained versus the investment required. And that's one way of proving to management, well, this is a worthy cause. And lastly, there's a lack of end-user training. Often when BI systems are implemented, users are not often trained to the degree where they're comfortable and competent again to do their own analysis. Again, similar to the one before, training is critical. There's no point providing a BI system if end users or management do not embrace that system. And so end users won't be competent in creating self-service if they're not trained in the ways of promoting self-service. So you can conduct regular face-to-face training or seek professional help through Tableau or through experts in the field. You can also create an FAQ guide, a frequently asked questions guide, or a product guide to help answer some of the questions that users, end users, or power users, or even just people within the organization might have. These are ways of promoting the use or the engagement behind business intelligence, and again, to help promote self-service. So there are many other challenges in creating self-service. These are just some of them. But tackle each obstacle one by one, and don't be shy to use expert help. There are many other people that have faced these challenges, including myself, but there are ways to overcome these obstacles. Something that I picked up on when looking at some Gartner research was finding the right level of service is the key to creating business intelligence and self-service. So the chart here shows what is the right level of service in traditional BI. On the left-hand side, they refer to it as the dull side, where everything is centralized and you have static reports built by an analyst team that provide information centralized to the complete organization. On the right-hand side, they refer to it as the dark side, where everyone is doing their own insight discovery, and it's decentralized, to a certain degree autonomous, and everyone is doing their own thing in regards to business intelligence. So you really need to strike a balance between information overload versus not enough information. And should it be centralized and should it be decentralized? That middle point is different for every organization, and particularly whether you're an end user or a power user. So power users are typically people that have different requirements from end users. And a power user is traditionally someone that is very competent in business intelligence and requires very granular information and does a lot of statistical or analysis functions with that information. An end user is usually a user that utilizes the system but doesn't need to know the mechanics behind it. So try to separate these two requirements because they're often different. They're often people that have different experience and from different backgrounds. And if you can separate those requirements, you might often have to build dashboards or reports that service those two individuals or those two groups of people separately. What's often worked well for me is by creating an SLA, which is a service level agreement, that is kind of the rules or the way that in which you'll operate between power users and end users. By setting those ground rules, expectation is set, and so people understand what am I going to do versus what am I going to get provided from an analyst group. So I'm now just going to cover off a few examples that I've built up as part of my experience that really embrace self-service. And the three products I'm going to show you are called Hero, DIMPLE, and Path. These are all built through my current employer, which is Anomaly. But I'm happy to share if there's any questions around these tools by contacting me with my details that I'll provide at the end of this presentation. So I'll just introduce each tool and then give a quick walkthrough about that tool. So DIMPLE is our ABS census cube, which is built through the ABS data, which took place in 2011. So the last census happened in 2011. It's publicly available information. And we extracted all the information from the census and built a cube around it, which is called DIMPLE. So DIMPLE contains de-identified information for 92.5% of the population, which is about just over 20 million people. So DIMPLE is not sample data, it's not research. It relates to about 10 million households in Australia and over 350 gigabytes of raw transactional data. So I'll show you in a couple of slides how we extract the data, but what we did is we collected over 92.5% of the Australian population, all the demographic data behind them, and cross-referenced it into a three-dimensional cube, which is what we've called DIMPLE. So all the data is geocoded, or geotagged, in terms of its Latin long, so we can show it on a map. We've then created a three-dimensional cube through DIMPLE where you can slice and dice through filters, for example, age, gender, and household income, and understand the relationships between those three dimensions. It's very fast and very interactive, so it is a big database sitting behind DIMPLE, but all the results are presented within seconds. So you can do a query within the front end of DIMPLE, which is built in Tableau, and get the answers to that question within a couple of seconds. And all the raw data, charts, tables, and graphs can be exported and can be incorporated into some analysis. So for example, if you're doing a segmentation project on age, gender, and household income, you can pull up those three variables very quickly and take all the raw data to where you're doing the analysis. So I'll now just switch over to Tableau Reader to show you an offline version of DIMPLE. So this is the front end of DIMPLE. I'm using Tableau Reader, but we have published this online onto the Tableau server. And we've published it on our private server, so if you need access to it, you can request it through me. What we have on the left-hand side is three filters to select the target information or the target people or target population that you're interested in. So you can look at age in terms of groups, 15 to 39, 25 to 44, and the information we extracted from the ABS data was age in single increments. We then created these groups because they're quite pertinent and relevant in our business. Looking at age, we've grouped them in the lowest level into increments of 5. And so I have all ages selected here. We then have languages spoken by the population, and there's no surprise if you look at the histogram that most people speak English. But there is a large population that doesn't speak English. Roughly 17% of the population speak another language other than English. And the third variable is a whole list of all other demographic attributes surrounding the Australian population. So here I have gender selected, and it shows me the distribution of gender for the Australian population. But I can select household income. And within a few seconds, what's going to happen is it's going to recompute and give me the results for everyone's age and everyone's household income and their language spoken at home. So now what it's shown me, the age and language information hasn't changed, but it's now given me household income broken down by increments that are defined by the ABS. So what we can see here is just 3 histograms showing us the distribution of those categories, of those variables. But very quickly, I could say, well, I'm interested in household income. And you can see here all the different options. But for example, let's just say I was interested in some high-earning consumers, and I wanted to look at their information. So what it's doing is not just giving me the high-end information, but it's also going to produce that and split that by age and by language. And what you see here for the high-end earners of the Australian population, we see then the representation in terms of the languages that they speak and the age demographics. Now the colour coding here just indicates whether it's above index or below index compared to the Australian population. So the ones in green are over indexed and the ones in orange are under indexed. So here's another example of a visual cue that straight away I can see and interpret this data that green indicates that it's a higher index and it's over indexed, and orange indicating that it's under indexed, and so it's underrepresented in this subset of people. It equates to roughly 1 million people. So the high-end Australians, high-end earner Australians of household income relate to roughly about 1 million people, which is 4.3% of the population. For that subset of people, I can look at their information and see where they're located. So what we get here is a table that shows by local government area. It's showing me the number of people that are aged in that local government area. So in Brisbane, there are 3,758 children aged 0 to 4, and you can see the total population. I can look at that by postcode, and the numbers automatically change. Or I can look at that by many other geographic splits. I can also change the different axes and look at household income by age. Sorry, household income by postcode, but I can also look at it by age. So what I've got here now is the 2 household income groups and the age distribution of those groups. Everything is sorted in descending order here in this particular case. So very quickly I can pull up a target group and then analyze the information about that target group. As I mentioned, every piece of data here is exportable, so I can take this table or the charts that are located up here, and I could copy and paste them into PowerPoint if I wanted to do a presentation. We've then heat mapped the Australian population to show the relationship of the surrounding geographical areas. So what we'll see here is the Australian population by postcode, the average age, and it's represented as a heat map, and the intensity of the colour indicates that that postcode has a higher age demographic. So there are pockets of Australia here where we can see visually they tend to have an older population. Now with Tableau, you can zoom in on any map, you can pan and scan, and really filter into that demographic. Now what we've done here is we've built up postcodes and created boundaries using lookups in terms of the latitude and longitude of those postcodes, and then associated the demographic information with that postcode. The last thing that DIMPLE does is it provides a correlation scatter plot between 2 variables, so you can analyze those variables like I showed you previously. And this is an example of the screenshot that I had previously. So I can look at it on a national basis or by state. I can pick a particular local government area if I'm interested in a specific geography. and I can pick a major city, inner, outer, or rural area if I had a particular geography of interest. I can then control what's on the x-axis and what's on the y-axis by using these parameter-controlled axes. And each dot here, as I mentioned, is a postcode. And what we get is a relationship between household income and age. And this shows the line of best fit. So as an analyst, I can analyze these two attributes and determine the relationship between them. If I wanted to look at English proficiency versus unemployment rate, as an example, it very quickly draws that relationship. And so there tends to be a lot of people which have a low English proficiency, and they relate to the unemployment rate of that postcode. There are obviously postcodes that are out of that relationship, and you can analyze the information behind that postcode. So DIMPLE is a tool centered around the Australian population. It's publicly available information, but we've created a Tableau cube around it. We license that to clients if they're interested, and for many clients that we've licensed it, we provide the mechanisms where they can analyze the Australian population and incorporate that data into their analysis, should they wish. So I'm just going to return to the presentation. So the nuts and bolts behind DIMPLE, we extracted a lot of information from the ABS website. So the ABS website is restricted in what you can actually pull. It restricts you. You can only pull a certain variable, a certain number of variables and a certain row length every time you want to request information. So we had to devise that down into about 1,200 files. Now that took about 8 months to download, to clean, and to analyze, and equates to roughly 350 gigabytes worth of raw CSV files. We then put that into our SQL server to cross-reference the information and to store it more appropriately, and to build the postcode files, postcode boundary files that you saw in the example, to which then we overlaid DIMPLE as a presentation tool. So some of the features that DIMPLE utilizes in terms of self-service is really dynamic filters. As I mentioned, if you select the population in the first screen, that can be filtered and selected right through from the map to the correlation scatter plot. All the data is completely exportable, and so the table you see in front of you can be exported into a CSV or to Excel. And so we're making information available, promoting self-service. We use heat map technology to help highlight hotspots. So again, visual cues here, the darker the intensity of the color, the more higher representation there is of that attribute. So it helps you analyze information more appropriately than just being presented by numbers. And lastly, the correlation scatter plot is a way to analyze information through a correlation scatter plot. So the next example I want to give you is path. And path is our approach to digital attribution. So digital attribution is a way of trying to understand what's driving online and offline conversion. And it's trying, from a multivariate perspective, what we build is a multi-touch model. And so many people might be familiar with the last click attribution model, which attributes success to the click prior to conversion. We build a multi-touch model, and so that looks at all the stages in the pathway before you get to conversion and attributes success to those publishers or to those events that drive conversion. And so what we're doing here is we're analyzing a digital footprint in terms of a cookie and all the ads that you can be exposed to in a day, in a week, in a month, and trying to understand what drives your conversion based on that impression activity. And so we incorporate a lot of data from an ad server, which has impressions, clicks, visitations, and conversions. And we're drawing a lot of data on a daily basis. If you can think about how many ads are there out there on the internet on a daily basis, how many banner ads, how many times do people search, and what keywords do people type into Google and other search engines. So there's a lot of activity that's out there on the internet just on one daily basis. And so for a particular client, we analyze what's driving their conversions. The model we use incorporates some learning techniques whereby it learns from past activity to predict future success. I'm just going to show you a very quick demo of Path. So on the first screen of Path, it shows me, and we've genericized it to reduce any confidentiality for our clients, is all the publishers that can drive a particular conversion. So we've genericized that and call that conversion 1. And it shows me all the different pathways and the conversion pathways that are actually resulting in an end outcome. So publisher 18 is no surprise that drives the most conversion, or drives the most activity that drives that conversion. There's many other publishers that don't really do much in terms of driving conversion. Now you can look at the dashboard on a daily basis, and this slider then shows how much data you're looking at. So it either restricts or increases the amount of data you're looking at. And then we can look at this by many other ways. We can look at it by publisher, by creative, by keyword, and by page. The real key feature that I wanted to show you of Path is the optimization page. So this allows a user to do investment scenarios by looking at different scenarios and predicting what's the impact on our business. So the models are actually built through R, and as I mentioned, R integrates with Tableau, where we download the data behind the scenes, the cookie level data. We build a model in R and overlay the dashboard through Tableau. What I've got here then is the investment scenarios for a particular week or particular day. And so this is saying, is this publisher, we spend about $10,000 and it drives 11 conversions. Well, what I can do is understand what happens if I invested more in that publisher, how much more conversions is it likely to drive. So right now I'm spending $10,000 and I'm getting 11 scenarios. What would be the likely output if I were to spend $11,000 on a weekly basis? So very quickly, what was happening behind the scenes is it's taking the number you input, it's calling the R procedure within the model to understand that input and calculate the desired outcome. What it shows me is that additional 1,000 doesn't drive any more conversions. And so I can play out scenarios to understand what's the ideal optimization or what's the ideal spend that I need to spend. So I can do that across many different publishers. For example, in Publisher 5, I can increase that to 15,000. And you can see the likely impact on my business. So the idea here with this example is it's taking information in that the user enters. It runs through the R model, the likely impact of that input, and then refreshes the dashboard to show you that impact over time. So I'm just going to jump back to the presentation to talk a little bit more about Path. As I mentioned, we're downloading cookie level data from an ad server on a daily basis. We're putting that into the SQL server to store and collect that information because of the vast volume of that information. We then run Tableau and the R call functions to update our models. and then we export the information that's in the Tableau reports into Power Packs for our clients. So on a typical basis, we're dealing with around 600 to 800,000 daily impressions per client. We have multiple clients that we run this for, this model. The process is completely live, so every day the data downloads from the FTP server, or the ad server, into our SQL database. We run the models over that additional day's worth of data and upload the data to the Tableau dashboard. The process is fully automated too. I as a client can log in, or I as a user can log into that dashboard and play out scenarios at any point in time, but also to understand what's the latest campaign results. So some of the self-service features that R utilises is one, that integration with R. Having R integrated with Tableau helps us to run predictive models within Tableau. And it employs other features like filtering or highlighting, that if I were to select a publisher across either tab, the optimization tab or the attribution tab, it would show me the results of that publisher. The last example I've got is called Hero. And Hero is our slice and dice reporting tool. We collect a lot of information from clients, whether it be sales, transactions, pricing data. We have a lot of media data that we collect, and there's a lot of third-party data that we have access to. So what we've done is we've consolidated all that data and built a skeleton which is called Hero. So Hero is a reporting platform whereby clients get all their information in the one place. It's all updated through APIs and FTP feeds. And so it removes the manual intervention of I having to copy information or send it manually. The platform is completely interactive, and so I as a user can interrogate the data that's on there. If I was a marketing director, I can log into the system and understand how's our sales tracking today, where are we getting our sales from, and how are we forecasting the sales for the next week or month. And it's refreshed in either real-time, daily, or weekly or monthly, depending on the client requirements. So I'll just give a very quick demo of Hero now. What we see here, and in this case, it's called Precision. We brand it as either Hero or Precision, depending on the client requirements. So what we see here is a lot of filters at the top that allow me to look at multiple campaigns or multiple periods or multiple transactions. So here we're looking at multiple campaigns that are running for a client. We can have a look at and understand what type of campaign. Is it a brand campaign or retail campaign? Is it a price campaign? What state was that campaign? What channel did we use? How did we collect information from that channel? And there's many other filters along the top too. What we can then do is graph that information and provide it in a tabular format. So here is the graph and the tabular information down below it, and also present information on a map. What we can show, you can change using parameter controlled axes, is what you want to display in those graphs or in that table. So for example, I can change this to gender, and all the information could be tagged by gender. So here we're showing you the responses by male, female, and those that haven't provided gender. I can change it to quarter, if I want to get a quarterly summary. And you can see again all the information recalculates and presented it in a quarterly format. I can change the y-axis and control whether I want to display leads or what we call paid responses, or CPL being the cost per lead. And finally, I can choose how I'd like to color it or group the information. So what we see is that, again, Hero is a way of slicing and dicing a tool, a report, into many different attributes that can control or that's in the ability to report on within the Tableau dashboard. For this particular client, we report responses or television activity or digital activity. And then just going to jump back to the PowerPoint again and talk a little bit about the nuts and bolts behind Hero. So on a weekly basis for this particular client, and for many of our clients, we're sent through automatic feeds, whether it be FTP or API, their client data, which is their sales, their transactions. We have all the media data, and there's a lot of third-party data. We then consolidate it into the SQL database and present it through Tableau. So really the self-service features behind Hero is that dynamic filtering. I showed you that I can select a variable and have a look at many different facets behind that variable. So I could change it between looking at a day, week, quarter, month, whether it be state, whether it be leads, whether it be responses. We also use global parameters for consistent filtering, and also dynamic filtering when it comes to the axes and parameter controlled graphs. So that really wraps up what I have to show you, and I just wanted to summarize in the key takeouts of this presentation. The true measurement of self-service, or the true success of self-service, is when users are informed by what they need to know, not necessarily what others want them to know. And true ways of measuring self-service that it's been successful is that analyst support requests and the insights generated are at a more acceptable level. So there might be 5 requests per week, 6 requests, not 100. If there's a large majority of requests coming through to the BI team, many of those could be common questions or common answers. And so we want to reduce the number of those requests to a manageable level. The requests should be more niche rather than generalized. And overall business confidence should improve as a result of self-service. So here are my details if you need to get in contact with me, or if you had any questions regarding this presentation. Thank you, and good day.